a bit. We didn't get into that last night with the Tuesday, Thursday group, but you guys only have 3 days left, including tonight. And they have 4 days, including last night. So they have, well, you lost a day. You're gonna lose another day with Veterans Day. So if you like holidays, you get more holidays on the Monday, Wednesday schedule, but you also don't get me as much. So we'll have to compress a little bit between tonight and Monday to catch up so that we can do implantation, fertilization on Wednesday. So when we looked at the male reproductive components, remember we had the gonads moving into the scrotal sac so that they were outside the pelvic cavity to aid in temperature regulation. Because when the boy is born, his testes have spermatogonia. They don't have any primary spermatocytes. And at puberty they continue to undergo mitosis and form ongoing from that time on more spermatogonia through mitosis and primary, secondary spermatocytes and spermatids through meiosis. When the female is born, her ovaries do not contain any oogonia. All right, those have all finished being produced in fetal life, and her oocytes are at the primary oocyte stage. So the temperature regulation is not an issue. Her gonads develop in the same position as do the male testes. They do not, they have structures that form from both the upper and lower gubernacula, but the lower gubernaculum forms ligaments of the ovary and ligaments of the uterus that move into the labia majora here, but do not pull the ovaries down in that situation. So if you recall, we had in the male, what was the structure that formed the Sertoli cells around the male gametes, around the spermatogonia? So if we look at the developing embryo, we have the genital ridge, and that becomes the testis, and in the female, that becomes the ovary. Right? So the genital ridge is going to develop into the testis in the male and into the ovary in the female. And so the testis and ovary are homologous structures. They're the equivalent components that share the same embryonic region. And then the oocytes, or the primordial germ cells, migrate up from the yolk sac, and the oocytes take place. They're placed here. So these are actually the primordial germ cells, which will become the oogonia, female. So in the male, it was the germinal epithelia forming this surface area of the genital ridge. And in the male, it surrounded the testes to form the seminiferous tubules. All right? So what were the walls of the testes? What do we call those cells that actually form the epithelial walls that surround the developing spermatogonia? What's the cell that forms the seminiferous tubule? Sertoli cell. Okay? So in the male, the germinal epithelium is going to form the Sertoli cell. In the female, it forms cells that individually surround each oocyte. And we call those follicles. All right? So the homologous structure in the female are the follicular cells. So that's what's happening within the testis. Okay? So what in the male is the next structure that we talked about as far as development? What do the mesonephric tubules form in the male? Remember? Yes, the etheric ductules. All right, so in the male, we write it in the other sequence. mesonephric tubules are going to form the efferent ductules. And that's what actually connects the male gonad, the testis, to the first part that develops from the mesonephric duct, the epididymis. So there's no chance for the developing sperm to get lost in the pelvic cavity or the peritoneal cavity of the male, all right? You'll notice as we look at female anatomy that the ovary and the oviduct are not continuously connected. The oocytes can move out into the peritoneal cavity, as can the sperm, if they're in the oviduct. So, in the female, this does not develop, okay? You can see remnants. We have a rather ancient model here of the ovary and uterus. And this structure right here is found in the peritoneum that connects the two. That's the remnant of the mesonephric tubules, okay? But they're not functional in the female. So they're not, there's no direct connection between the gonad and the tubules. All right? So then in the male, the mesonephric duct forms what structures? Okay, epididymis. Vas deferens. Ejaculatory duct. And the prostatic urethra. And then what three glands? Those develop as an outpouching of the epithelial tissue of the mesonephric duct. So all of our glands. Seminal vesicle, prostate gland, and bulbourethral are also developing from the mesonephric duct. So seminal vesicle, prostate, and bulbourethra. Does a female have any of these structures? Actually, yes, 2. Yeah, it was officially decided in 2002. See these sets of glands right here that secrete into the urethra? Their old name is Skene's glands, but they're currently called paraurethral. And for a long time, women were claiming that they ejaculated at orgasm, and they were poo-poo. Now that's just urine coming down the urethral tract. But if you test it with pH, it's not acidic. And so these glands were, they're not hard to find, but they're now considered to be the equivalent to the homologous structure of the male prostate. You may have heard of the G-spot. So in the male, of course there's no vagina. So in the male, sexual orgasm can be increased by manipulation of the anal canal against the prostate gland, which is going to be right here. In the female, you can have access to those through the vagina, and the anterior wall of the vagina can increase sensation by manipulation of those Skene's or paraurethral glands. So in 2002, they were officially decided by the Anatomical Society of whatever to be the equivalent to the prostate gland. So that's the only portion of the mesonephric duct that remains in the female. Okay? So what does develop in the female? Where does our oviduct come from and our uterus come from? You remember what disappears in the male?
The paramesonephric.
Paramesonephric duct. All right? So in the female, the homologous structure, it's not the same as, but it's the equivalent to this because this disappears in the female. The paramesonephric duct is going to form the oviduct, also known as the uterine tube or fallopian tube. It forms that the oviducts fuse together to form the uterus. And then the upper third of the vagina. So how this forms the prostatic urethra, just the upper third of the vagina, most proximal. Okay? All right. So all of that out of this slide. So here is a diagram of the undifferentiated reproductive structures. Now the cells here would either be male or female, so they're going to have the XX chromosomes in them, or the XY, so it's not like it's undetermined, okay, they just haven't been expressed. So, of course you can still have, you can have XYY or XXY, it's not like you can't have any of those other components. So here the mesonephric duct is disappearing, all right, and the paramesonephric duct remains, and as you can see there is no continuous connection between the ovaries and the oviduct. Then it fuses to form the uterus and the upper third or so of the vagina. The lower third develops from the embryonic structures that form the bladder and urethra. So let's look at the clay animation for the female. Maybe easier just to go directly to. So we looked at this last week for the male, and so we'll see it now for female. So that's the pronephros, which has the same inductive influence. We're seeing the mesonephric tubules here. So the female still develops this, it just doesn't remain as a functional component. And then we'll put the body of the mesonephros over that. So everything's so far looking the same as it did with the male. And now the ovary is going to be seen here as the rest of the mesonephros disappears. You can see a little gray body coming down. The true kidneys are forming here. So it's this region down here of the mesonephric duct that's going to contribute to the periurethral glands and the bulbourethral glands. So now the blue is the paramesonephric duct, okay? And again, there is, mesonephros is degenerating. There's never a direct connection between the paramesonephric duct, which fuses now to form the uterus and vagina, okay? It's occurring posterior to the bladder there. And mesonephric duct degenerates, and then we have the ovaries, the oviduct, the uterus, and the upper portion of the vagina, okay? All right, so question number 1. In the female, the mesonephric duct is going to form which of the structures I have listed up there, if any?
Yeah. Okay. Cool. It sounds like we.
It's somewhere here.
Okay.
Scantron?
Yeah, I'll give you one back later.
You're good.
Follicular cell, right? No?
It's not.
I didn't get a chance to finish that part.
Yeah.
Guys doing well? Anybody want more time on this question? Okay. So this just kind of summarizes how the germinal epithelia here are forming the seminiferous tubules, whereas in the female, they're forming not a ring, but that's what it looks like in cross section, but a ball. So let's look at some of the slides similar to what I showed you for male. So here's the genital ridge, all right, that's going to form the ovary. Here's the germinal epithelia that's going to form the follicular cells around the what are going to become the oogonia. We still have the mesonephric tubule around the blood vessels from the aorta. Here's the mesonephric duct, and here's the paramesonephric duct, all right? So based on what we talked about over there, you would expect these structures to all disappear and this to remain, okay? So you can see now the mesonephric tubules are degenerating. You can see that instead of forming the seminiferous tubules, we're seeing isolated balls of cells forming around the primordial germ cells. Here's what's left of the mesonephric duct, but we still have the paramesonephric duct. And now instead of having seminiferous tubules, we're seeing the follicles. All right. Question number 2. In the male, the cells of the germinal ridge form the sustentacular or Sertoli cells. In the female, this embryonic tissue, the germinal ridge, the epithelia of the germinal ridge forms what? And I've kindly reviewed this already for you. It's up on the board.
I just want to feel like yourself.
Okay, alrighty. So now let's take a look at the ovary, which is the first gonad, the only gonad here. By the way, in this image, which is a frontal or coronal view, you're not getting quite the same idea of the tilt that you see here. So, although it's often diagrammed like this, the vagina and the uterus are not in a straight line like this, okay? It's actually more like that. I can do this without as much embarrassment as a male teacher might do, or Jeff, but I'm going to be the female reproductive system, okay? Up here is the top of the uterus, oviducts, legs are the vagina, cervix here, okay? So the table will be the desk will be the bladder, and the uterus is bent almost at right angles over the urinary bladder. The oviducts are not out like this, like it appears up there, they're actually pulled back, and the ovaries are behind the uterus, okay? They're not out here like that. There's not much space down in the female pelvis, or the male for that matter. The female just tries to put more in there. So that's the actual orientation, although with childbirth or even with development, the uterus can be up like this, or even back. So in its normal position over the bladder, that's called anteflexion or forward bending. I have a diagram of that a little bit later. Any position more upright than that is considered retroflexion, okay? All right, may I erase the board? I know I may, but without conflict from you. All right, so if you recall, when we talked about the testis, and don't worry, we're not going to go through all the layers of the scrotum or the spermatic cord because the ovary does not move through that, so we don't have those structures. But if we have the peritoneum, the ovary is developing posterior to that, just like the testis did. And what did we call the ligament that attached to the superior aspect of the testis and connected it to the posterior abdominal wall? Gubernaculum. But we have two. So this one is the upper. And it disappeared in the, degenerated and disappeared in the male. It's going to remain in the female to become the suspensory ligament of the ovary. All right, so the suspensory ligament of the ovary develops from the upper gubernaculum. Then on the lower border here of the ovary, we have another ligament. And that, of course, is going to be the lower gubernaculum. In the male, this one went all the way through the inguinal canal and attached to the internal surface of the scrotum, the adipose tissue of the skin, and as it shortened, it pulled the testis down through the inguinal canal and into the scrotum, okay? Obviously the ovary stays in the pelvis, and so this actually becomes attached to the uterus before it then attaches to the equivalent structure of the female, which is the labia majora. So here's the uterus. And I'll redraw it for its structures. So this ligament actually passes through the uterine wall. So between the ovary and the uterus, this becomes the ovarian ligament proper. So it's going to be this structure right here. Okay? So this will become the ovarian ligament proper. And then, uterus is a little lopsided. And then as it passes through the anterior wall of the uterus, it passes forward and out the pelvic cavity. You want to know the name of that opening? What's the opening in the male that the gubernaculum testis is going to pass through to get into the scrotum sac? The deep inguinal ring. So in the female, this is the deep inguinal ring. We'll come back and talk about this ligament when we talk about the uterus. And the rest of the lower gubernaculum is known as the round ligament. And there's one on this side too. Okay, we're just putting in one ovary. So lower gubernaculum develops into the ovarian ligament and develops into the round ligament, which is a supportive structure of the uterus. Okay. So I'm gonna move ahead a little bit with the slides, just to show this to you before we actually get to uterine structures. Here. This is a diagram from Netter's. And this is posterior, so we're looking at the sacrum and the rectum. Here's the bladder and the pubic symphysis. Remember how I described how the oviduct was pulled backwards and posterior? So here's the suspensory ligament of the ovary, which is developed from the upper gubernaculum. Here's the ovarian ligament, which is developed from the lower gubernaculum. And here is the round ligament passing forward and through the deep inguinal ring. Okay, so it's the structure that keeps the uterus in that anti-flex position, pulled forward. Now, where did the gubernaculum testis end up? Attached to the bottom of the scrotum, okay? The homologous structure in the female for the scrotum is the labia majora, which we'll talk about at the end, but it's the fleshy fold that has hair follicles in it on either side of the vaginal opening. So, I'll just jump ahead to show you that so you have it in mind. Okay, so this is the labia minora, which is going to, in the male, fuse to form the shaft of the penis. And here's the labia majora. So anchored in that would be the end of the round ligament. Okay, so that's all that we have in the female inguinal canal. It's just that round ligament. We obviously aren't going to have the ovarian artery or vein because there's no ovary in there. Okay, there will be nerves going to the labia majora, but no other structures. All right, so question 3. We actually only have 4. No, we have 5. Put a 5th one in there. So in the female, the paraoophrys, what you see here, and what I showed you on the model here, is a remnant of what male structure? So just saying it's a male structure helps you knock out some things, right? All right, so what is the connecting structure in the male that allows the sperm to move from the testis into the epididymis, but is absent in the female, so we have no direct connection, okay? So if I in the male, if this was male, it would be doing this. And that's absent in the female. What is it in the male? What does it develop from?
Yeah.
Okay. Connects the testis to the epididymis. Okay, you ready to move on? Let you think about it a little bit more while I erase the board. May I erase the board? Everybody has what they need from that? Anybody want more time here? So you can see that the internal structure of the ovary is very different than the internal structure of the testis, with the absence of the seminiferous tubules. So when the girl is born, her egg cells are primary oocytes, and they remain as primary oocytes until she reaches puberty, and then one or two will mature and be released as a secondary oocyte. By the way, and we'll learn this next week, the secondary oocyte never divides again unless it's fertilized by a sperm. So it's the binding of the sperm to the egg that triggers it to make a secondary oocyte and then go into the ootid. So the ootid's actually the secondary oocyte's already gonna have that head from the spermatozoa in it when it divides to form the ootid. So it doesn't stay an ootid, it forms a zygote pretty quickly. So because I'm trying to combine the hormonal cycles, I split Thursday's lecture for the Tuesday, Thursday group into today and Monday. We're going to talk about the follicles now, so I'll tell you what page to move to. But this diagram is a chronological diagram. In other words, we start out with this follicle, and then it matures until the egg is the secondary oocyte is actually released, and then it convolutes to form endocrine organs secreting progesterone. But the oocyte and the follicle do not move through the ovary like this. This is just showing you the different stages that they go through. If this is the oocyte that's going to actually be released, all of these changes take place right there. Okay, so it doesn't move around within the ovary. So all of these follicles are found in what's called the cortex of the ovary, where the ovarian artery and vein come in and supply blood from the central region, which is the medulla. We don't have those types, more like what we have with adrenal gland. We don't have that in the testis. All right, so if you would turn to page 114 in the lecture packet, we'll just move ahead to that portion and discuss these follicles here instead of waiting till Monday. So I use, because of my histological training, I use different names than your textbook does, okay? So let's look at these follicles. So first of all, a follicle is going to have, and this is starting at the time the girl is born, a follicle is going to have in it a primary oocyte. Okay, we don't have any oogonia when we start talking about the ovary after the girl is born. Then, until puberty, the follicles are surrounded by those cells that develop from the germinal epithelia, the follicular cells, and they are a single layer of flat squamous cells, flat and squamous being the same thing. So your textbook calls this a primordial follicle. I do not. So just in case you see that and you're wondering, I never heard that word before. We're going to identify that as a primary follicle. Okay? So primary oocyte surrounded by a single layer of flat follicular cells. Those cells that develop from the germinal epithelia instead of the Sertoli cells. So this would be equivalent or homologous to Sertoli cells. Okay? Then, several of these, and we'll talk about those hormonal changes on Monday, but several of these under influence of, guess what, LH or FSH? FSH, because these are follicular cells, so they're influenced by the follicular stimulating hormone. So several of these follicles, under the influence of FSH, still containing primary oocytes, will develop a single layer of cuboidal cells. And then more cuboidal cells. Still a primary oocyte because it's not a secondary oocyte until it's actually just a little time before it's ovulated. So a lot of these never become ovulated and never become secondary oocytes. So whether it has a single layer of cuboidal cells or multiple layers of cuboidal cells, this is now a secondary follicle. Okay, so still follicular cells. So either one, a single layer or multiple layer, if they're cuboidal in shape, secondary follicle. Now, as it's developing into a secondary follicle, it develops a thickened protein coat that is, if it is ovulated, is one of the barriers to polyspermy. Helps to prevent more than one sperm from adding its DNA to the egg. And so this coat of protein, not a crackable shell, but it forms a covering around the oocyte. And this is identified as the zona pellucida. Okay? So the sperm have receptors for proteins on the zona pellucida and vice versa. And that's where our species specificity comes from.
So quickly, the
Yeah.
zona pellucida is a thickened layer of what?
It's a protein.
Protein.
The protein coat that surrounds the egg. And over here in our model, so here is an egg that's been fertilized by a spermatozoan, and this blue shell is the zona pellucida. Okay? This is fertilized, it's going to divide, it's going to keep dividing and keep dividing and keep dividing until it actually is hollow inside. This one has only gotten to 4 cells, but it's like hundreds of cells, each cell is smaller, and it still has that zona pellucida on it. Okay? So that doesn't rupture until this gets into the uterine cavity. It has to rupture if we're going to have implantation into the uterus. Okay, so we'll talk about that next week.